So good afternoon, everyone. I'm Jean Danumah. As Professor Boigny already present myself, I'm here to present assessing the extent of flash flood zone in Grand-Bassam using Google Earth Engine and vehicle method. My outline will be as you can see. I will start by an introduction, a study area. I will present the data, the material, and the method used, and I will end it with the result and a short conclusion. So floods are among the most devastating natural disasters in the world. We all know that. Although they are natural phenomena, their causes are heavily influenced by human activity. But in 2024, floods affected more than 4.4 million people in West Africa and Central Africa from OSHA 2024. Countries in West Africa and Central Africa, such as Nigeria, Niger, Cote d'Ivoire, Senegal, and Democratic Republic of Congo, Burkina Faso, Mali, and Chad have experienced severe flooding during the different raining season. Based on that, what is the justification of our work? The justification it is that in Cote d'Ivoire, several cities like Abidjan, Yamoussoukro, and Niamey are not spared from natural disaster. And for example, in 2024, we got 30 deaths during the flood that occurred on June 14. Grand-Bassam is not related to this natural disaster caused by flooding. And according to Kwadjo and al. 2020, several neighbors in Grand-Bassam, such as Mosul, Petit Paris, and far neighbors, have areas that are particularly vulnerable to flooding. And in the same year, 2024, we got one death and extensive property damage during the flood in Grand-Bassam. This gives the necessity to look at what is going on and try to find some solution. So this slide shows an overview of what has happened on this 14 June in 2024 in the study area with real area flooded. And now I will forward to the study area. What you have to know is that Grand-Bassam is an historic town and also a UNESCO World Heritage Site now since 5 years ago and situated in the southeast of Cote d'Ivoire, about 40 kilometers from Abidjan. And the area is about 126 square kilometers. What is the material that we used during this work? It was ArcGIS software. We use JavaScript as a programming language, and we implement our work on the different platforms, Google Earth Engine and Google Drive. The data that we use are from diverse sources. We have satellite data from radar images, Sentinel-1, Sentinel-2B. We have also the digital elevation model from ALOS Pulsar. As a precipitation satellite data, we used chips, and we are also able to use the Copernicus Global Human Settlement layer to be able to see the demography, and also the surface water data from the global surface water. And we combine them with different administrative limits. What are the methods that we use? The first one is the vehicle method. Vehicle method is a multi-criteria optimization and compromise solution. It's a multi-criteria analysis method developed by Professor Sarafin since 1979. The vehicle method aims is to identify the most appropriate alternative from a range of viable options by balancing ideal and non-ideal solutions. The application of vehicle method involves several steps. The major steps I cited here: decision matrix, normalization of factors, weighting, calculation of vehicle indices, and the ranking, and finally, the classification. This gives you an overview what is the flowchart that we implement based on the different sources of data we were able to develop the land use map, population density map, the slope, the drainage density, precipitation, and soil types. And using the vehicle method, we were able to do the different classification and the reclassification. And at the end, we were able to now get our final result, which is the flood risk area map. For the Sentinel-1, for the detect of the change for the flood using the Google Earth engine, we were able to use the UN Spidey script that they make available for all of us and just modify it to give the different range of the period that we want to see, we want to search. And this is the flowchart of how we were able to do our work on this Google Earth engine using the UN Spidey mode. We select the study area. We try to get now the data from Sentinel, the radar one, and we do some composite, speckle, smoothing, empirical threshold, putting some value there, and now apply the flash mark refinement, and now we get the final flood extent. So this is the flow chart of what we've done on the Google Earth engine. It's important to know, to remind you that we use the UN Spider framework script to do this another word. So these are the results that we got. We were able to elaborate several maps on each factor, slope, land use, and at the end, we were able to combine them as a VCOM method authorized to now get our flood susceptibility risk map area of Grand-Bassam. And you can see that we have 88% and 3% of the study area that are very low risk of flooding, but we have 42 and 15 areas within the study area that are high and very high risk of flooding, but also do not negligent the average one, because we can, after the study, we were able to reveal that 34% of the study are moderate risk. Moderate risk is also important to take into account. If you want to combine them, you can see that over 75% of the area are very vulnerable to flood. And combined to that one, because the aim of the study is to combine a mitigated approach to also merge them with the Google Earth engine to see if it fit or not fit. So for the result from the Google Earth engine, you were able to do the binary raster layer, illustrated the difference between the image before and after the flood on 13 June and 14 June 2024. It highlights the intensity of the change for each pixel. In particular, the light pixel reflects significant change, while the pixels show minor change, the black one. For the flood extent of the 14 June event, after processing, the Sentinel-1 change detection workflow identified a final flood extent of 964 hectares from the 14 June 2024 flood event. Considering a study area surface of 126 kilometers square, this corresponds to approximately 7.6% of the study area that has been flooded on this day. And now we were able to now to see the exposure indicator by overlay the result to Google Map, Google Earth, and as you can see, the flood extent we already said it, 964 hectares. The exposed population was about 782 people, and the affected cropland was about 508 hectares.
Dr. Danumah, okay,
Yes,
hand up,
please.
please. Thank you. Thank you,
Yes,
hand up.
the last one, the conclusion, what we can say after conducting this research, the result of the vehicle indices illustrated the spatial distribution of flood prone area, an area with low with low rate, Q indexes close to zero, therefore considered to less vulnerable to flooding, and conversely, area with high and name it Q index that is close to 1 are considered to vulnerable to flooding. The study map for the flood extent associated within the 14 June 2024 event in Grand-Bassam and estimated exposure-based potential damage indicator used the Sentinel-1 images on Google Earth Engine. Both results can serve as a decision-maker tools to assist local authority and policymaker in taking decisions to solve flash flood issue in Grand-Bassam. This is the end of my presentation. Thank you for listening to me.